Hello, this is Ramsey Rashid, part 2 of the CS464 database class demo of the final project. What I'm going to go through right now is show some of the code that I wrote the website used to interface with the database, reading and writing data. Um, so there are many different ways in which you could write an application which stores and retrieves data from the database. The purpose of this class was to demonstrate that you can do so in a raw format. So we're not using any special libraries or anything. We're using a standard ADO.NET connection with some raw queries. So essentially, each time any of these queries are ran, the entire raw text is sent across the wire. This is not ideal in the real world. You'd want compiled queries that reside on the server, but nonetheless, we'll go ahead and go through the examples. So there are many different ways to have done this. We could have embedded the queries, throughout the website itself, scattered. But we have so many pages. We'll take a look in our Visual Studio project here. Um, we have about 40 different pages throughout our web application, so it doesn't make sense to have our queries scattered around willy-nilly. So instead, I created something which is pretty standard called the DALC. I just named it the DALC. It stands for Data Access Layer Connection. Pretty standard procedure, and in here, this is kind of like a factory design pattern, if you will. It's pretty much a class that you call the methods statically, and these methods are either inserts, updates, or retrieve. There's a couple of deletes, I believe. So I'm going to go ahead and demonstrate a couple of them, and then you guys will probably get the idea of exactly what's going on. So the first thing to show is the connection. So the MySQL connection, this is an actual .NET object. This object here is what's going to connect us, it's what's going to connect our web application to the actual database. And I have another factory pattern here called the base connection manager, and then it has a method called get standard MySQL connection. We'll go ahead and go there, navigate to definition, and we could take a look at exactly what this function does. So it simply returns a MySQL connection using an internal static function, getting the actual connection string, format that MySQL wants it. So that's all this is. We have one connection that we will use statically and sling it across the different queries as needed. So video one, we demoed registering for an account and logging in and sending a message and uploading an image and all of that. So I'll go ahead and brief on some of the queries which allowed that. So the first one was creating an account essentially when we logged in, and that is done through this method right here. It's called create profile for account, and it's an insert statement. This is basic raw text, and as you can see, there's an array of parameters. I think we have 20 parameters. These correspond to the columns that we see when in the actual MySQL database. So all of these columns here have a corresponding value through these parameters. And this code right here, lines 544 through 563, we're essentially hydrating our command object with the parameter names and the parameter values. The reason why we're using parameterized queries is to avoid any kind of potential SQL injection. This doesn't limit it 100%, but it certainly does a great job of doing so. So the interesting thing about this particular query is we're going to be utilizing a transaction because we're inserting a record into two tables, and we either want the entire thing to succeed or the entire thing to roll back. Here's the first insert statement and the hydration of all of its parameters, and here's the second insert statement and hydration of all of its parameters. And then we begin our transaction object, and we assign the connection to the transaction object. and we execute the first query on line 594, and then on 595 we execute the second query, and then we do a commit. Remember, depending on the isolation level that you choose, which we went with the default, the data won't be visible by anybody until it's, or it won't be persisted at all until we commit the transaction. So there's an example of a generic insert with a transaction. Let's take a look at now retrieving this profile which we just created. So I believe I have a function here which not only gets you a profile, but it hydrates a C# object that we created. Now this application was written in C#, but the same paradigm exists in just about any language, Java, PHP, etc. So we'll go ahead and open this one. I have two profiles. Sometimes I have a user ID and I want to get the profile. Other times I have the profile ID. If I wanted to really be intelligent in the design, I would have just made one. I would refactor this into making one and call the other from within the other, but that's beyond the scope of this video. So this is more of the same, except instead of an insert statement, this is a select statement. And we only have one parameter here, which is the profile ID. So we're selecting all of our attributes from the profiles relation, where the profile ID is whatever's inputted. And then, assuming we have one, which we have a reader object here, which does the reading. If this returned multiple, tuples, our reader would iterate through all of them. But in this example, we will only ever hope for it and want one. So here's our profile object. We create it up here, and then we hydrate it down here with all of the data. And we close our connection, assuming there's no exceptions. Always good habit to close your reader as well, or use a using statement, which will invoke an automatic dispose on the end. And so there's a good example of simple select. One last example we can see is the actual binary image. So we'll go ahead and go there. So I have what's called a web handler page. If you're familiar with ASP.NET, you know exactly what this is. If you're not, basically this is a page that doesn't behave like a normal web page, but instead it writes binary data to the output stream. So you can do stuff like create images on the fly without an actual image being stored on the database or on the application server. It reads from the database instead and writes it out in a binary stream. And that's sort of how we're taking advantage of the fact that our images are stored in the MySQL Server database. So I'll show you the function here which generates the image, and then I'll show you the actual image as you can see it through a web browser. If you remember from the demo video 1, we were able to upload pictures of Peter and Lois and view them. They were all using this function right here. So basically, our web page will have a query string which will give it an image ID. This image ID is the actual image ID from the database, 1 through n, whichever image that we're interested in. And we do a simple select image, which is going to be a binary column, a binary attribute from the images table, where image ID is the parameter that we just put in. Theoretically, this limit 1 shouldn't be there, but for safety's sake, in the event that somehow we have two images with the same ID, which shouldn't happen, but it is there because I'd rather not have a user see an error message, if you will. So again, we have our MySQL command object using the same connection from the factory, so we're not ever using too many connections. We're sharing a connection per each client. So we're adding the parameter that was passed into the query string, and we're executing this select statement through a reader, which we just discussed. However, this time, instead of getting an attribute like a text string or an integer or a decimal value, we're getting a byte array. And it's really simple. We simply call the reader's function on that column name, on that attribute, which is the only one that we selected, and we just simply cast it to a byte array. And it's a one-to-one cast, and it's pretty efficient. And then from there, we just tell the content type of the output here that we're outputting an image, and we do a binary write of the binary array for which we just cast it. That's all there is to this. In a perfect world, of course, if we didn't find The image ID that was referenced, our else clause here will simply output a generic image, which is stored on the server itself and not in the database, but it's directly on disk on the application server. But in most cases it'll always find it, and to show you an example, we're going to navigate to this page in Firefox, and I'm already there. So here's our image handler page with the image ID and the query string, and it generates a picture, in this case of Lois, to the output header. Now this picture of Lois is not stored anywhere on the application server. This is binary data in the database. And we'll go ahead and change the image here to image 3, and let's see what happens. So I'm going to change that to 3 and hit enter, and we see another image of Lois. So she's in there a few times. We'll hit 6 and see Brian. So we updated it, the image ID to 6, and it found it associated that image with Brian. So again, that's using this binary code here, and it's simply going to the images table in our database. So let's do a quick select star from that table, and it's called images. And as you can see, here are all of the image IDs. The actual data is in this image column, and the profile ID is going to be our foreign key, which connects it to the profile. So that wraps up the generic method paradigm that I used to interact and interface my ASP.NET web application, final project for CS464 at UNM with MySQL Server database backend. This is Ramzi Rashid. If you have any questions, please shoot me a message on YouTube. Thank you.